Imagine now, instead of learning from a 2D whiteboard, you can project, let's say, information to your eye directly. And here what you see is called a glass brain project. And it shows you all the intricate connection for the neurons firing. And with Meta, you can see all this detail otherwise not possible to see. So, of course, if you think about the human, our eye is the best sensor of a kind for your body. We have millions of sensors on your retina to help you to see color, to see the brightness. Imagine you blindfold yourself today. I don't think anyone can easily get out from this door. And if this is the best sensor of a kind, how much better could it get? The funniest thing I'll say is, if you look at the human eye, what we can see is only very narrow spectrum. From this spectrum of the color you can see, I'll guarantee your dog and cat can see more than you, even today. But our evolution, I don't think in the next 50, 20 years, you can see into the X-ray, you can see into the radio. But the technology today, we do see X-ray that help you to diagnostic on the cancers. You see radio, your phone pick up the radio, and helping you to communicate. What if all this can be advanced, and what we can advance on? First thing I think, personally, right now this light is blinding me. I cannot see you almost because the bright sun or the bright light on my eye. Our eye is extremely limited with the dynamic range. So on your cell phone today, you may all notice one feature called HDR, high dynamic range. What the computer can do now is they can take multiple shots of the same subject matter and then create a much more rich dynamic range. But I don't think you can do that with your eye. Today, everyone wears glasses for very simple purposes, either for safety, corrective, so allow you to focus so you can read, magnification, so you can see a bit better, getting a bit more resolution out from it. Or some of you just wear it for the look, which I do that sometimes. But if we put a digital form, imagine now the computer is on your eye. This, what you see is an example of my professor, actually, Steve Mann. He built this prototype about 40 years ago. So this is actually in the early 90s. So you may all find it really funny. But just look at the cell phone you had in the beginning. It looks really funny as well. So this is the MIT Media Lab. People trying to understand what if you have a computer on your body. But most importantly, they're trying to put the computer on your eye. And on this side, you can see that is my professor, Steve Mann, who often referred as the father of wearable. I'll give you a story. So when I first met him, he actually looked like this. This is the actual glasses he wears in everyday life. So when he walked into the class, I was learning, I was a student. He said that you can have your exam open book, open to the computer, but not open to the internet. Okay, so he told me, I can catch you if you're cheating because my eyeglasses can detect Wi-Fi. That moment I was like, oh my God, right? So how is it possible? Because in an analog way, it's very hard for us to imagine that your glasses can see the unseen. So from there, I started the journey, that 10 years of prototyping. Prototyping is the way to learn. First problem I try to solve is this problem, the dynamic range. I would like to have an eyeglasses can see so well, it may look a bit funny here, but see into the brightest object, which is TIG welding, and seeing the background at the same time. So with this, you can see the glasses has the camera situated exactly positioned as your eye. And here's what it can do with it. If you all weld, you know that with the analog shade, you only see the bright dot and nothing else. You feel like you're working in the dark. In the dark, that is very dangerous because you're playing with very high voltage and currents. And with this digital form, we can now create guidance. You can teach people how to weld. You can make people to see much, much more. And with this, we figure, what else can we do? What else would I want to see if I have a way to compute information in real time? So Steve and I worked closely, and he envisioned that we can also visualize all radio waves. So imagine you hold up your cell phone now. How many times you're trying to find the actual hotspot? But you've been walking around like this, like, okay, I get a bit better signal, worse signal. But with these glasses, now you can visualize where the radio is coming from, so you can get the best reception. And guess what? The best way to hold the phone is not like this, but like this. Because I learned that the antenna is coming from this back of the phone. And I know that what will make the phone more effective. So seeing the unseen is very fun, actually. We actually created a prototype to see depth. So imagine now you can resolve things about like this far, but give you millimeter accuracy. From there, I built the first prototype called Meta. I walk around with it proudly. So here what you see is a notable scientist, Gordon Bell. He's been wearing cameras for decades. But the moment he put it on, you can see that big smile. He was shocked. It's like, wow, this allowed me to see much better. That's impossible, even with analog glasses. He actually can now see exactly how far things are, and he couldn't in the past. And I think we all know, even as a great idea, it's worth sharing. We start doing this on the street. I was doing demonstration, getting more people to try it. And everyone started to tell me, Ray, I really want to have this. Can I buy this? And I was thinking, maybe we should sell this. That brings us to Meta 1. We're thinking about now, if you can bring all the digital content that live around us into the real world, what can we do now? Imagine you do 3D printing. You can now preview exactly the size of it before you put into the printer. Think about the digital and the real world are now truly connected. And what can we do with this? The important thing is by shipping, I'll say, a product, right, we learn a lot. So when I ship this product, it's nowhere near perfect, but we learn one thing. The customer start to know what they need and what they want. Everyone comes to me and say, I want better resolution. I want better field of view. I want to make it see more naturally for my eye, so it's not constraining. It brings us to what we're shipping soon today, the Meta 2. You can see a dramatic change in the design. One thing you notice is the optical engine. So what you see right under the brows is a single piece, semi-transparent visor. And that has all the optical elements to project information to your eye. And most importantly is you can still make eye contact. And you can see the beautiful face of our designer. This is actually our industrial designer, Martin. And when we think about the problem we're trying to solve is the field of view, if anyone try glasses in the market today, most of them looks like a small rectangle that you can look through. But what we're interested in is having that immersion. We learned that it's actually very important because if you have a small field area, it loses the illusion. It feels like that the content disappears in front of you. And with Meta, we achieve the bigger rectangle that you see and give you the sense of presence. And the important thing is this. We have very wide peripheral vision. So we can see almost here if you put your hand out. And by designing the optics around our eye, we learned that now we can achieve a lot of almost impossible tasks in the past with these glasses. So let's dream a little bit what the possibilities are there, but it will be the reality very soon. One thing we learned is by wearing glasses, now you turn your whole body as an input. You're thinking about your brain as what you need to program on. You want to give you a sense of present, right? You want to touch things. That's what babies do when they're young, right? That's the best way for you to learn. Now imagine all the digital content. You can interact directly with your hand. We call it the neuroscience interface. So it actually works with your brain instead of alienating us, like using an iPad that you have to look away. And the most importantly is you can engage them as if they're a real physical object, and you can program them to work a specific way you like. Imagine an architecture firm. You want to show your customer what you're building. What's the best way you can do it now is using 3D models, and it takes a long time to build. What if now, by wearing the glasses, you can demonstrate exactly how big things are, or give them a sense of the space and understanding what you're getting? That will change the way we communicate and collaborate. For education, I think all of us knows learning from a textbook in a 2D abstract way is really difficult. And if you are medical students, you know that to learn through the human body is a lot and a lot and a lot of work. What if you can see everything, your vein, your nerve system, all in true size, and overlay it directly on top of it? That will make people engage much quicker and having that sense of spatial. And this is very important for a lot of us because that's what our brain does. For shopping, I think the number one problem for shopping today is you don't know what you're getting when you're shopping online. You just see a picture representation of it. What if you actually can have the object in the real world and you see it and you can put it on? Imagine you're getting the shoe, now you can fit it on, see if it fits. And for girls getting bags, I think that will save you a lot of time, possibly. And for designer, I think with these glasses, we can create objects in space much more freely. Because now you can create without thinking about the cost of the material. You don't have to get clay. You can just draw and create in space. I asked a lot of artists. A lot of time they spend is to understand how to project this 3D information back to the 2D world using perspective. But now what if the whole world is your canvas and you can draw on? And lastly, I think for communications, well, we are travelers here. We know how hard it is to, separate from your family. So I live in California, San Mateo. My family is in Toronto, Canada. And my brother is in Boston. Having that family time is so difficult because just physically it's hard for us to travel. We can think about future of communication is we now can have a telepresence. Because with the advance of 3D sensing, you can see that very soon I can be in a space seamlessly as if I was there. What you can do more is you can even collaborate. So I can pass around 3D objects from each other and creating, collaboration seamlessly. So in the next couple minutes, I'm gonna take a look at there because I will show you the Meta 2. And give me 1 minute. Yes?
Vivez avec vous. Okay. Okay. So this is the first time that he's going to be doing a demo on stage. So if it works, let's all applaud, and if it doesn't, well, we'll just smile and... But I'm sure it will, because you give so much importance to demo.
So, I guess a lucky day for everyone here today. So I do have a demo. So here let me demonstrate, oh man, I'm so happy right now. Demonstrating how I can interact with these 3D objects with my bare hand. Look at the accuracy I can get. I can touch individual one the way I want it, right? And I can move 2 hands and move it around and even scale it if I wanted to. Whoa, all right. Well, thank you. Remember the glass brain project? Now I'm the expert for a second because I can reach out and learn much more about the brain. And for people who want to do education, that's the best way to learn. That's the best way now you can engage with the content. And most importantly is, if all of you here wearing these glasses today, you can also see what I'm seeing. And seeing the world that's unseen right now, all the digital content can be lived around us. And at Meta, we build the most natural machine for your brain, for your body. And we hope that everyone here will join us in this journey and make this the future of the computing. Thank you very much.